So similarly, right now we're going to be discussing the last part of the table, the last part of the Laplace transform table, which is when you have cosine of cos omega t and you're asked to transform this, right? This is the same thing as s upon x squared plus omega squared. Now this is the same thing as 1 all over 2 that upon s minus j omega plus 1 all over 2 upon s plus j omega. Now you should recall that this is the imaginary part and this is the real part. You can check complex number on complex number. The video is you can check it in the comment section below, so you can get more on complex number, right? So we are asked to transform sine omega t. Now this is just going to be omega upon s squared plus omega squared, which is just 1 all over 2 the imaginary part of s minus j omega, then minus 1 all over 2 imaginary part of s plus j omega. So what's the difference? S for sine is s, for sine is omega, for cos is s. Then the difference is here you don't have any imaginary part, but here you're dealing with the imaginary part. Then we have, when you have cos omega t and you have a just a shift, then this is going to give you s cos phi minus omega sine phi, right, upon s squared plus omega squared. Now similarly, if you have e raised to power at, right, then cos omega t. Now we have done this. You can just multiply them together, but for emphasis sake, you see this is just what you have over here. You just have s plus a into a plus a raised to power 2 plus omega squared. How cool is this? Just straightforward. So similarly, if you have exponential at sine omega t, so what are you going to get here? You're going to get omega upon a plus you have a plus, here over here you're going to have s plus a squared plus omega squared. How cool is this? Is this just very, very cool and straightforward, right? I think it's just simple as that. So anytime you're going to use this transform, always recall that for t to be valid, for the function to be transformed, t must be greater than or equal to 0. This must hold, because in the general formula for Laplace transform, remember, you're integrating from 0 to infinity. And the concept of infinity, if you don't know anything about infinity, is just a relative large number, So you can watch some previous videos that we have in our channel. There is a playlist dedicated for Laplace transform, which we are going to be dealing with. Now, before I should end this video, I am going to talk about the inverse of a Laplace transform. So the inverse of a Laplace transform, what is it? Inverse of a Laplace transform, S, F, S, then you have f of 0. Now, this particular inverse, we are going to be talking about it in details. When you have the function, the inverse of the function, or you want to take the transform, the inverse of the transform, we are going to be discussing it in the next video that is coming. So thanks for watching this video. If you have not watched the part 1, part 2 of Laplace transform, please you should do that. Then get the table. You can get the table anywhere and look at it. Then you can try and memorize as much as you can. But for the proof, You can watch some in the examples, and we're going to be proving more and more of this transform table as we continue. If you have any topic, any question in particular, one of the solve, put it down in the comment section.